Hi everybody, this is Benedek here, very welcome to my channel. In this video I would like to show you how to create a simple but fairly useful randomly generated procedural dungeon maze in Unity and C#. First, let's check out what will be our end result. So what we will try to achieve now. As you can see, it is a randomly generated maze, and here we have walls and little corridors where we can move around, and we can have, you know, a little bit more space here and things like that. Even we can try to generate, let's say, holes in the floor and things like that. So if you are interested in, please follow along. And before we dive deep into this whole stuff, please consider subscribing if you haven't already. That helps me to grow this channel, and this is much appreciated by me. Okay, let's get into it now. Alright, now we are in a completely empty brand new project where we will build out what we seen in the little intro demo. And first things first, we need to import some visual assets in order to you know, have the wall blocks and things like that. So for this I've found already good asset, the dungeon models, and I have some prefabs: the ceiling block, the floor block, and the wall block. These are just prefabs, or with another word, prefabricated objects. So I'm just gonna copy them and just you know, show in Explorer and go to the assets folder of that project and just hit Ctrl+V to import them, and now it is just, you know, compiling and things like that. I will put them into a Google Drive folder, and I will, you know, include a link in the description section of this video so that you can import these assets also and you can use them. And as you can see, we will use this this ceiling block, this floor block, and this wall block for our generation. But before we start, we need to have a character so that we can move around and explore our scene with ease. And for this one, I've found a good and easy to use Unity Asset Store asset. It is the starter assets first person controller. Actually, it is the successor of the well-known standard assets. So currently standard assets is deprecated, and we are encouraged to use the starter assets presented by Unity for us. So I'm just click open in Unity and open in Unity editor. And it brought up the package manager for me. It is fetching my assets, and if you haven't downloaded it to your computer, you have to first download it. I've downloaded it, so I can just import it. I don't wanna untick anything, so I'm just hit import again, and it will take a little bit of time, but it will import all the starter assets kit, and I will get a first person player from there, and I can use that in my scene so that we can move around and explore and verify if it's if our random dungeon maze generator will work okay or not. Okay, it says a little warning that we have to enable these backends, so I will just hit yes, and I recommend, I think it is the recommended option. Alright, the starter assets package is now imported into our project, and we can find our character controller, and it will be the first person controller, and we will go to the prefabs and we will use the player capsule. So I'm just gonna drag and drop it here, and we need to assign actually a main camera under the player camera root. I will delete the default one, and here we can have a main camera which has Cinemachine, brain, and things like that. So I'm just gonna drop it there under the player camera root, and I think that will be kinda cool. And I will just, you know, I've modified the original player, so I think it makes sense to pull that here to my prefabs folder and create a new prefab with that variant, and I will rename it to my player. Okay, that will be our player. It is just for having something to test with. Okay, now as we have all the building blocks for our maze generator, we can start actually. I will create an empty game object, and it will be the dungeon generator. Okay, and I will create a scripts folder here, and I will place my dungeon generator there. So create C# script, and it will be the dungeon generator. Alright, I opened it in Visual Studio so that we can start. Actually, for simplicity, I will delete everything, and I will create some other things before we start in the scene, because I've just forgotten to create two objects which will be very handy. So I have to create a parent object for our floor. So I will call it floor parent, and I will I just hit Ctrl+D to duplicate it, and I will rename that to be the was parent, so that whenever I spawn instances of these prefabs, I will generate many instances of them, and they will appear in our scene. Now, if I wouldn't create a parent for them, and it would go into the hierarchy directly without having a parent, then our hierarchy would be a mess. So that's why I've created those parent objects. Alright, now head back to our C# script. Can now create our script. Okay, so I will create the game object variables for the prefabs so that we can assign them in the inspector, and we can instantiate many of the floor prefab, of the wall prefab, and of the ceiling prefab. Okay, so we will assign them on the inspector. Cool. Now we will create references to the game objects of the parents, which I've mentioned and just created, so that our hierarchy won't be very messed up, but it would be, much more structured. And now I'm gonna create a game object reference to my player object. That will be the FPS controller object, which I've just dragged and dropped into the scene from the Unity starter kit, remember? And I will create a public boolean variable. It will be called isRoofNeeded. It will be useful because I want to have a way to open the roof of the whole maze, so that you can have a better insight into it, how it works and how it looks from the above. So that's the idea of that bool. And now I'm gonna create a new variable called tiles to remove. That will be useful, and I'm initializing it to 350. That will be useful because we will generate our dungeon maze as a kind of boolean, two-dimensional boolean matrix. So we will create a two-dimensional array, and we will fill this array with whole true values, meaning that true values will represent walls and false values will represent spaces, free spaces. And the thing is that I want to generate this maze, the structure of the maze, in a way that I will initialize this two-dimensional boolean array or collection, let's say, in a way that everywhere I put was, and then I will clear out some tiles, and it could be, fine-tuned how much tile I wanna erase, meaning that I could have more free spaces and more corridors, or less, and this is for fine-tuning it. And now I will create another variable called maze size, and it will be actually the size of the maze, meaning that our two-dimensional array or boolean matrix will be the square of this value. Okay, now I'm creating a boolean variable called isPlayerPlaced, and this will come handy when we will place our player at the very beginning in the maze generation. And I will create the Boolean two-dimensional array or matrix, the map data, which will represent where we will put was and where there will be free spaces. So this will hold our logical structure. That will hold the logical structure of our whole maze. So that is very important. Okay, and now I will create the logic for generating our maze data, so generating the map randomly. So I am creating a private function. By the way, in C#, if you want to have a private function, you don't have to always put in private, because if you don't say public or protected or any other access modifier, variables and functions and even classes, it will become private automatically. So I can erase the private from there as well. Only public access modifier is needed to tell that they will be public. Okay, now I am creating the generate maze data function, which will do the trick. Actually, here I'm gonna initialize another collection, another two-dimensional matrix, of which will be called data. And here I put in maze size and maze size. So actually the block count of our, yeah, and I should have new keyword here. So as you can see, as it's a matrix, as it's a two-dimensional Boolean array, and it has currently 30 by 30 as the size, actually its size is 900. So there will be 900 blocks in that collection. If I would say 10 here, it will be 10 times 10, so it will be 100. So the square of the maze size, basically. Okay, now as I mentioned, we will fill it in a way that we will initialize all the was to true, meaning that everywhere I put was at the beginning, and I will clear out the ties to remove quantity blocks afterwards. So that's the trick. Actually, I am iterating through the maze size with a for loop, and I have to do it twice, as you can say, because it is a two-dimensional array. So that is why I am iterating through every column, and after that I am iterating through every row. Okay, and now I am indexing into this matrix, and I am initializing everything to true. So I am filling in the whole maze, the whole holder of the maze, the whole map with was. Then I will clear out the was somewhere in the quantity of ties to remove. Okay, let's do it. Here I will have an integer, so a whole number variable, and I will call it tiles consumed, and it will be what we will increment, so that we will keep track whenever we reach tiles to remove amount. But at the beginning it will be 0. Okay, I am initializing a maze x and a maze y position to 0, and we will keep track where we are with them inside our iteration. And now I am gonna just iterate with our random crawler and clear out the was needed, so that we generate free spaces here. So I will do it with a while loop. And the condition is probably something which you have already found out yourself also, but this will be it. So we will iterate until the tiles removed will be equal to the tiles to remove. So until it is less, we will do our job. So that's the condition of the while. And here I am generating in every iteration a direction x and a direction y, and I first initialize it to 0. Then I will get a random value, and random value will just give you a random floating point value, so a float between 0.0 and 1.0. and it is an inclusive range, meaning that it can be either so it can be also 0 and also 1 and anything beyond. Okay, so I'm generating a random value, and I say if it is less than half, so it is 0.5, then the x modifier, the x direction, will be another random, will be based on another random, and in this case I will do this. So whenever our new random will be lower than 0.5, then x direction will be 1, and another case it will be -1. And here I am putting in an else statement, and the value here is more than half, meaning that anything beyond that to 1. In that case I will do this assignment as the same, but I won't assign it to x, but I will assign it to direction y. This is the way we can handle, the corridors and things like that. And now I will just try to find a random number of spaces to remove in this line, so that I won't accidentally clear out the sides of our maze, and I can do it like this. So I am generating a random integer here with the random.range, and I will go anything beyond 1, and the maximum amount of numbers to clear is maze size -1, so that we don't clear out the edges of our maze, because that wouldn't be so nice. Okay, and now I am going to just iterate on that amount of space which we require in this current line to be cleared out, and I will just assign the maze x to metf clamp maze x dot x direction, and I will put in here 1, and here I will put in maze size -2. And as it says, clamp will give us a value between a range defined by the minimum integer and the maximum integer, and it will return the given value if it is within the min or max or so. So that is the whole purpose of math clamp. And I will put in maze y also, and here I will also change it to y direction and maze y. Okay. And now I will just index into our map data with those variables which show us the current position. And what I wanna do, if it is true, so it is a check. If it is true, it is the exact same if I would say it equals with true, but we can, do it in a shorthand way without the equal true. So if it is true, meaning that there is a wall, which at the beginning obviously will be true to everything, then we will assign a false to it, and we will here increment the tiles consumed, so that we will somewhere end this loop, because we are going through this whole thing until we reach the tiles to remove the requirement, and this is how we can do that. Alright, and after this iteration and this clearing thing, we can return the data, which is our Boolean two-dimensional array, or the matrix. So it is the map. Actually, this is how we can randomly generate a map for this. And now I will create a new method which will be useful for us to actually generate prefab instances and assign a parent object to them. This will be useful for our walls and our ceiling and other things. So create child prefab instance. I will call it that way, but you can call it anything. The first argument will be the prefab, so the object template from which we will create a new instance. We will then get in the parent object, under which transform we will spawn that object, and we will pass in here a spawn position, meaning that where this object has to be spawned. And now I will create a var new game object, and I will use the monobehavior instantiate method for this. I will pass in the prefab, and I will pass in the spawn position, and I will pass in quaternion.identity. That means just no rotation. That is, needed because it asks me to give in a quaternion rotation, and this is why I am putting in quaternion identity. I hope you can see it like that. Okay, now I will just use that new game object, and I will use the transform of it, and I will assign its transform parent to be the parent game object's transform. And that's it. That is how you can spawn a new instance of a prefab and assign it under another game object so that it will be the child of it. And now what I am going to do, I will close that off so that you better see it. And now I will generate the maze actually, and generate the prefab instances, because we just created the methods for it, but we didn't really use it. So we will use it on the start method. So at the very beginning of the execution of our Unity game. And as I mentioned, we can erase the private access modifiers as they are, by default coming for us. And I will initialize the map data, which is just here, this variable. I will initialize it with the generate map data or maze data method, which we just created. And now I am going to create the real objects on the scene based on that template which is provided us by this two-dimensional matrix. Okay, so now I will need to iterate through the maze size, and as it's a two-dimensional, as we discussed it already, we will have to iterate twice. So first on each column and then on each row. And this is how we can achieve that. And now we will use a similar check we used earlier when clearing the data or clearing the walls. We will now check if this is a wall or not. As you remember, I said if there will be a wall, it will be a true value, and if there won't be a wall, so if there will be a space, that will be a false value. So I am checking the map data collection or matrix if its zx value is true or not. But I can do it without the equal true. So if it is true, I can use the create child prefab instance, and I will use the wall prefab here, and I will use the walls parent so that it will go under it. And I am creating a new vector free, and the x here will become the x here, and it will be 1 on the y, and it will become z on the z-axis. And I am gonna create 3 of it, so that because one block is of size 1, 1, and 1, meaning that 1 meter in Unity world, and that's why I have to create 3 of them to be a big wall. And else, so if it is not a wall, so if it is a free space, and if our player is not placed, so is player placed is not, so it is not true, I could use again not equals to true, but using the negligation exclamation mark is better, I think. So in this case, I am going to, get to my player object and its transform, and I will set the position and rotation, and it is a good function because it says the world position and rotation, not the local one. It can be a mess if you always use the local position, and I am going to use the current x and z as it is not currently a wall since we are in the else here, and I will use quaternion identity here, meaning that no rotation again. Okay. And I will say is player placed, and I will put it in here true, meaning that in the next free space our player is not moved again. So we will place our player as soon as possible. First time we encounter a free spot, we will put there our player, and we won't move it afterwards. Okay, now we will create our floor, and floor will be everywhere. So we don't need the conditions every time when we reach a block. let it be a free space or let it be a wall block, we will have floor in our maze. And if the roof will be needed, we will create roof as well. Okay, so here I will use the ceiling prefab, hops, and I will put it under the walls parent, as I didn't created a separate object for it, and it will have the 4 as the position here. Alright, I think we are done with it, so we can try to test it out and build it out in the scene. So go to the dungeon generator object, and we have to find our script, and we can just drag and drop it here, and as you can see, these are not assigned yet. So I have to assign those. So floor prefab will be the, under the prefabs, the floor block. I just drag and drop it, and the wall block, and now comes the ceiling block, and now I have to assign the floor parent, then I will assign the walls parent, and finally my player will come there. And note that it has a first-person controller and especially a character controller. So in order to have it working properly, we have to fix a serious bug. If game object has a character controller on it in Unity, you cannot directly modify its transform from script, because that will be overwritten by Unity. So we have to enable something called transform sync. So I am going to open up the preferences, and not that one. Okay, so I am going to open up the project settings, and I will go to the, so I opened up the project settings and I went to the physics. So you can go here, say project settings, and there will be physics, and make sure to tick this little checkbox called auto sync transforms. This will resolve a serious bug when you have a character controller. You cannot modify directly the transform of the player when auto sync transforms is off. So make sure that it is on. And now let's test our solution. And here we go, guys. As you can see, it is working properly. A little bit, I think our player is big, so that is why. So it seems a little bit odd. So let's just try to resolve it. Yeah, I will put in 0.6, 0.6, and 0.6, and save and restart. And yeah, it is the same as we had in the intro, as you can see. So it is working. There are, you know, corridors, there are bigger spaces and smaller spaces. So I hope you like it, and if so, please consider subscribing to my channel. There will be many more other Unity related and programming related stuff out there, so I think that will be helpful for you as well, and also for me. And have an absolutely wonderful day wherever you are. Be safe out there. Bye bye.